So how are we going to make a choice for K? Okay. And for that, remember, we have to divide the data set into training and validation. Okay, so that's important. You cannot do away with the validation set. So once we have done that, then you take each observation from the validation set and find the distance between that observation and each of the observations in the training set. So here are the training set observations, so which are from here, right, 2 through 23. Okay. Now these are the observations from the validation set. Okay. So now, in order to compute the distances easily, and so we want this to be represented this way. Okay, instead of being rows, you want to be columns. Okay, and how do we do that? We can do transpose. Okay, highlight this entire area and then type transpose close parenthesis, and then transpose is an array function, so you have to finish this by pressing Control Shift and Enter. Okay. Align it properly. Okay. Now we need the distance between each of the observations in the validation set. So this is our validation set. That's validate. So the distance for the first observation in the validation set to each of the training set. Yeah. So that would be square root of sum x minus y squared. Yes, sum x and y 2. Okay. Now we want these two values. Okay, that should be absolute referenced, comma. Okay. The training set right here. Those two values. Okay. Close parenthesis twice. So that will give us the distance between the first validate observation and the first training set observation. Okay. Okay. Now I'm going to change the absolute reference slightly, so we will be able to copy this all over. So we want to be able to copy this across this way. Okay. So your columns should change, but when you go down, the B38 and B39 should come from 38 and 39. So that is the absolute reference, the partial absolute reference that we need. So now when we copy down, you'll still have B38, B39, but when you copy across, you have C38, C39, and so on. And you want the opposite here. Okay. You want the columns to remain the same, but as you go down, the rows should change. So it should be like that. Okay. Now if you copy this down, so those are the distances for the first validate observation to each of the training set. Okay, so let's put the border back. Now if you copy that across, so now we have for each validations observation the distances. So now if I'm going to illustrate this for k equal to 3, suppose if you want to use k equal to 3, we want the 3 closest distances, okay, for each observation in the validate set. And for that we can use the function called small, okay, and we want that, and once again the rows must be fixed, the column should be able to change, okay, comma, the k value should come from here, and here the column should be fixed and the row should be floating. Okay. So that gives us the smallest distance. If k equal to 1, that will be that. K equal to 2, the second smallest distance, and the third smallest distance. Okay. And you can keep going for, you know, if k equal to 4, k equal to 5, and so on. I'm going to illustrate this only for k equal to 3. Okay. Now you copy this across. So now we have k equal to 3 distances. Now, but what we want is what are the events for k equal to 3. Okay. Now for that we have to first figure out the smallest distance. Here like 2.83 is train observation number 4, and train observation number 4 is the owner. So that's what we have to construct here. So we have to first find the row number. Okay. This is more a Excel assignment or Excel problem than anything else. So what I'm going to do now is to figure out, okay, what the observation number is for these 3 distances, the 3 closest distances. Okay. Match that. And there is a third one, match type, and that is less than the value, exact match, or greater than the value. So what we want is exact match. So 0. Okay. So now the value is matched against this range, and the position number or the row number is displayed here. Okay. So now we have the row number for the smallest, second smallest, the third smallest. Now we can figure out the ownership using